This video is going to show how the CPU works. We can picture the CPU like this with three sections: the control unit, the registers and the ALU. Within that are the four registers that we need to know about for our exam. We will look at all of those and what they do in more detail in a moment. On this side of the screen, I've got the RAM, just to give an example so that we can run through an example of how the CPU might work using data from the RAM, as we know that the CPU fetches data from the RAM as part of the fetch, decode, execute cycle. The first section we're going to look at is the control unit, which is what controls the flow of data in the CPU. Inside the control unit is the register called the program counter, and the program counter holds the next memory address to be used. That's how it keeps track of where it is within the program. So as we move on to each instruction, that will increase. The arithmetic logic unit, or the ALU down here, does all of the maths and the logic calculations for the CPU. The register inside the ALU is the accumulator, and the accumulator holds the result of all the calculations. So any calculations that take place, the total is kept track of in the accumulator. Then we've got the registers, and we've got two here: the memory address register and the memory data register. The memory address register, as the name suggests, holds the RAM address of the instruction that is being processed. The memory data register holds the actual data that is being processed. We're going to look at an example now using this bit of data that has been added into our RAM. So we've got some instructions and a couple of pieces of data. So 3 instructions and 2 pieces of data. The basics of what's going to happen in this program is it's going to load what's in position 5, or what's in address 5, which we can see down here is the number 8. Then it's going to add whatever is in the address 6, which is 4. So we're basically adding 8 plus 4. And then it's going to store our answer, or our total. It's going to store that into address 7. So that's how our program's going to work. And we're going to look at how the different registers are used as we do that. First of all, we've got the memory address of the next instruction, of what instruction is going to happen next, goes into the program counter. This is where we're keeping track of what instruction we are going to be working on next. That gets copied over into the memory address register so that it knows where it's going to fetch from the RAM the data that goes in the memory data register. So we know where we're fetching the data from, position or address 1. So we fetch that piece of data, which in this case is our instruction load 5. We know that load 5 means it's going to load whatever data is in position 5 over here. So that is now going to be executed. It's going to do that. So it's going to take the number 8 and it's going to put it into our accumulator, which is keeping track of our total. That's our first instruction executed. So what happens next is we move on to the next instruction. So our program counter increases, which means that we know now that we're going to move on to our next instruction. That gets copied over into the memory address register so that we know where we are fetching our data from in the RAM. We're now going to fetch it from address 2, which means that that instruction goes into our memory data register. We know that add 6 means it's going to take whatever is in our address 6 over here in the RAM, and it's going to join that in with what we've already got. So it's going to basically total it in our accumulator. So that instruction is now going to be executed, and we're going to take the number 4 and we're going to add it to our accumulator, which gives us a total of 12 because our ALU has done the maths and we've now got the total, which is 12. We're ready to move on to our next step. So we move our program counter up by 1 as well, and that gets copied back over into the memory address register. We now know that we're fetching the data or instruction from position 3, and that instruction will go into the memory data register so that it knows what it's going to do next. That instruction is to store 7, which we know in this example means it's going to store our total that's in the accumulator into address 7. So we execute it, we run it, and it takes our total of 12 and it's now placed that in address 7 of our RAM. And that shows a very simplified version of how this CPU would work with those instructions.